What else? Let's proceed to feature engineering. So we'll now manipulate the data so that it's ready for machine learning. So in some cases, you want to create additional columns or additional data, additional variables. How do you do that given this? For example, you start with this, you want to create more. So why is it important for machine learning? Well, then data mining and machine learning, they require mathematical representation. It has to be in numbers. So if, say, for example, your data is in text, you have to convert it into numbers first. So you have to do these things. You have to manipulate the data. You can't feed it as it is. Why is it also important for visuals? We're limited in the number of dimensions that we could show to the users, to the people, because we can't comprehend lots of dimensions. So we use this to determine, well, we have to determine first what we want to show and then do feature engineering to show what we want. So there are different types of feature engineering. There's feature transformation, feature generation, and feature selection. So transformation is transforming the existing features into something else through mathematical functions or formulas. Feature generation is creating a new column or feature. So feature generation, creating something new. And feature selection is just selecting a subset of those features that you think is relevant for your use case. Examples of feature transformation, you could apply logarithmic or exponential or whatever function that you could think of. You could bin the numerical values into categories. You could do feature scaling or standardization or normalization. That's all transformations. As for feature generation, for example, as I mentioned earlier, if you have text data, then you have to convert it into numbers. So it has to be a numerical representation. And you could do that using bag of words or count of words or word vectors. You could look it up if you want to. Those are NLP techniques. I actually have one later. I'll show it to you in my notebook for these things. For image data, the good thing is it's already in numbers. When you have an image data, it's simply in RGB format, and they're all numbers, essentially. So it's kind of straightforward to plug it into a machine learning model. But you could still do some feature engineering with it. You could turn it into black and white, or change the aspect ratio, or make it more pixelated. There's so many things that you could do. You could also get the edge features. As for audio data, you typically do MFCC or mel frequency subshell coefficient. So you transform the original raw signal. So it's in time domain, and then you convert it into this. Then now you could feed it into your machine learning algorithm. Okay, what else? Yeah, I already mentioned this. Yeah, they do require numerical values. So you have to do feature engineering to prepare it for machine learning training. What else? Examples of feature transformation, label encoding. Yeah, it's in the pre-processing notebook that I've given you weeks ago. So use it for ordinal categories. Small, medium, large, 1, 2, 3. One-hot encoding. If there's no ordering, there's no inherent order in the cities that we have in here. So it should be in one-hot encoded format. But what else? Count encoding, it's just a count. Extracting temporal features, there are so many things that you could get from time features. So you could get the day of the week, month, year, time of day, and many more. And it could help in your machine learning modeling. You could get better scores if you extract those additional features. Feature selection, there are two ways that you could do. One is manual, so you cherry pick the features, and it relies heavily on domain knowledge. You have to be an expert. How do you know that this particular feature is helpful in terms of training your machine learning model? I don't know. As for the automated one, you could use statistical techniques. Say, for example, you drop the ones that are not correlated with your target feature. Or you could use another machine learning model to determine which ones are good enough to be candidate features for your final machine learning model. So that's an automated way of doing things. What else? You could also apply dimensionality reduction. If you remember in the previous sessions, I've discussed that as you increase the number of dimensions, the data points become more equidistant with each other. That means they will look like the same eventually. So you need to reduce the number of features. And the good thing with reducing the number of features is it's going to be faster to train. Because if there's just so many features, it will take maybe days for you to train the model. So yeah, in some cases you will have to do dimensionality reduction, especially with big data. Questions? One.